Hello again. This is week 51 and time for the next episode. But before we dive into it, please subscribe. And if you like the content, hit the like button. This is the only way that I can know if you're all enjoying this, and it costs you nothing and just helps me understand what content you all like or dislike. This week's episode is about crema. People judge coffee by the crema. Too little, it's weak. Too much, suspicious. Big bubbles, cheap. But here's the truth. Crema isn't foam, and it's definitely not a decoration. Crema is physics, and in the capsule coffee, it's engineered. Today, we're going to break down what crema really is, where it comes from, why it behaves the way it does, and how we design it to be stable. Let's start by killing the biggest myth. Crema is not foam. Foam is trapped air, like soap bubbles. Crema is something completely different. Crema is a temporary emulsion made up of carbon dioxide gas, coffee oils, hot water, and pressure release. No milk, no detergents, no injected air. It exists because gas is escaping from the liquid under pressure, and coffee oils briefly stabilize that gas into tiny bubbles. And that's why crema fades. The gas escapes, the oils separate, surface tension collapses. Crema has a lifespan, and that's normal. So the first question is, where does that gas come from? Crema starts long before the capsule ever reaches a machine. It starts in the roaster. During roasting, coffee beans trap CO2 inside their structure. The darker the roast, the more the gas is retained. Grinding accelerates the gas release, which is why grinding is so critical. In capsule coffee, we deliberately trap a controlled amount of that CO2 inside a sealed environment. Too little gas, weak crema. Too much gas, unstable crema. This is why degassing windows matter so much. Crema doesn't start in the machine. It starts in the coffee itself. That's why you see a little bulge on the capsule. That's the pressure inside the capsule, trapped there. Now let's talk about pressure, release, and micro explosions. Inside the capsule, coffee is brewed under high pressure. The gas stays dissolved. Oils stay mixed. Everything is compressed. Then, at the exit, pressure drops instantly. That sudden pressure release causes a rapid CO2 expansion and microscopic explosions in the liquid. Coffee oils tear into tiny droplets, and these droplets coat the gas bubbles, stabilizing them just long enough to form crema. This is why pressure alone doesn't create crema. Pressure release does. Crema is born at the exact moment pressure disappears. Now let's talk about bubble size, the real quality signal. Here's something most people get wrong. Good crema doesn't look dramatic. Bad crema does. Large bubbles mean uncontrolled gas release, weak oil stabilization, short lifespan. Small tight bubbles mean controlled pressure release, good oil emulsification, and a stable structure. The best crema is tight, even, and calm, not frothy or bubbly. Next is the flow rate versus crema. Crema lives in a narrow window. If the flow is too slow, gas is trapped for too long. The crema becomes thick and muddy, and bitterness increases. If the flow is too fast, gas escapes instantly, the crema collapses, and the body disappears. The engineering goal is balance. Enough resistance to form the crema so much that the extraction suffers. And this is where the grind distribution, densification, tamping, and capsule geometry all come together. Now let's talk about the crema color. It's a visual extraction sequence. Let's talk about something people notice instinctively. The color of the crema isn't about aesthetics. It's information. In capsule coffee, crema color gives you a fast visual indication of the extraction balance. Here's how to read it. A very light, pale, almost blonde crema usually points to under extraction, flow that's too fast, insufficient contact time with the coffee, or a grind that's too coarse. In other words, the water passed through the coffee too easily. At the other extreme, a very dark brown, almost reddish crema can indicate over-extraction, flow that's too slow, excessive resistance, or too many fines in the grind. That's a sign of the coffee was pushed too hard for too long. What we're aiming for is a balanced crema color, hazelnut to caramel, even across the surface, without dark spotting or extreme light patches. That color tells us the extraction window was right. Not rushed, not forced, and this is important. Crema color should be stable, not evolving wildly during the first few minutes. Rapid color separation or dark patches forming quickly are often early indicators of extraction imbalance. So when we look at the crema in quality testing, we're not just asking, is it there? We're asking, what is it telling us? Crema isn't just about coffee. It's also about the hardware. Internal filters in some capsules controls fines migration. Then the physical filters in the machine also affects the crema. Lid perforation and hole size controls how fast pressure is released. The number of holes affects turbulence, embossing patterns, and shape flow paths. Change a lid spec, say, from 30 to 40 micron, and or the annealing process, and the crema changes, even with identical coffee. This is why crema is engineered. Now let's talk about decaf. This is crema on hard mode. This deserves a special mention. Decaffeination removes more than caffeine. It changes the bean structure. Decaf coffee loses CO2 earlier, produces more fines, releases gas less predictably. The result, a weaker crema, larger bubbles, and a faster collapse. If regular coffee is hard to engineer, decaf is brute. Here's another myth. Fresher is not always better. Coffee that's too fresh contains too much CO2. That can cause unstable crema, excessive bubbling, erratic flow, even capsule swelling. This is why degassing matters. Capsules need a sweet spot. Not too fresh, not too old. Controlled gas equals controlled crema. Now, crema is a quality metric. At Eurocaps, crema isn't subjective. It's measurable. What about key quality performance indicators is crema stability. Our benchmark is simple. Crema must remain stable for a minimum of 6 minutes, not 30 seconds, not 1 minute, 6 minutes. Why? Because stable crema tells us the gas release is controlled, oil emulsification is correct, grind and flow are balanced, extraction is repeatable. It's not about looks, it's about consistency and performance. What crema really does for your cup of coffee? Crema contributes aroma retention, mouthfeel, visual appeal, but it does not equal strength, and it does not guarantee quality. You can have a great coffee with modest crema and a bad coffee with beautiful. Crema is a messenger, not a judge. So in closing, crema is not a decoration, and it's definitely not luck. It's the visible result of pressure, gas, oil, flow, and timing, engineered into something that lasts just long enough to enjoy. The golden layer tells a story, and now you know how to read it. This has been Engineered Coffee, so we'll see you again in the next episode. And as I said in the beginning, if you enjoyed this, please hit the like button and subscribe. We'll see you next week.